Good evening, students. My name is Shashank Shekhar, and we are doing a crash course on chemistry for the upcoming JEE exam. And today is our 44th day. So, we have started the chapter Biomolecules. So, yesterday we have completed the carbohydrate part, that is this one. So, today we will be seeing all the rest of the part, which includes protein, vitamins, nucleic acids, and hormones. So, we will see all of these remaining ones. So if you want, this is the topic in the detailed manner. The first we will see about amino acids, so specifically about the alpha amino acids, which is in the syllabus. Then the isoelectric point, then classification of amino acids. Then we will see some examples of amino acids and how they are distributed based on their functional group. Further, we will move to protein and look upon their structure, starting from this primary structure, secondary structure to tertiary and quaternary structure. So about protein, this was much, and then we will see an example to define the structure in a more easy way. Then we will move to enzymes, vitamins, at last the formation of DNA. So we will see the DNA and RNA at last, which includes basically about the nucleic acid and all. So this is all about the topic in detail that we'll be covering today. So we have seen the weightage earlier also. So it has a total question of 1 marks, which is of total question of one question, which is of 4 marks. So let us start the chapter. So first, I want to make one thing clear here is that we have to only focus on alpha amino acid. So beta amino acid and gamma amino acid are not in our syllabus. So what do you mean by alpha amino acid is that both the COOH group and the NH2 group are attached to the same carbon. That is this one. So this is the basic structure of alpha amino acid. Now next, in aqueous solution, the acid carboxylic acid and basic amino acid. So when we dissolve this amino acid in water, it is not present in this form, rather it is present in a Zwitter ion form, in which the COO is present in the form of carboxylate and NH3 ammonium ion. So this is the structure that is mostly present in the aqueous form. So this is the aqueous form of amino acid. Again, it is also called as dipolar ion because it has a kind of ion creation here, dipolar ion over, okay. So this is the structure of alpha amino acid. Now next, let us see what is isoelectric point. So we have seen earlier in this slide that okay, this atom that is existing in water is overall you can say neutral because there is a positive sign, unit positive sign. So there is a unit positive sign and there is a unit negative sign. So overall, the charge on this is 0. But this charge or the overall charge on this amino acid can be adversed by changing the pH of the solution. So we will see it how it happens. So amino acid exhibit both amphoteric character, means it can be both acidic and basic. How? So in acidic solution, the amino acid becomes cations. How does it become cation? By taking the H plus. So the the amine group that is present, it takes the H plus and becomes NH3 plus, which is a cation. And this cation moves towards cathodes in an electric field. So you know it very well that cathode is negatively charged and cation will move toward that cathode part if the amino acid is given the acidic condition. Next, the alkaline solution. So if it is a basic solution, then the amino acid will have a negative sign on it because the carboxylic acid that is present will be present mostly in the form of CO minus and the NH2 will be present as it is and it will migrate towards the anode. Now how we'll do it? We'll do it by changing the pH of the solution, but it is not necessary that since 7 is neutral, so if you increase it to basic, then it will become the anion, and if you make it acidic, then it will become the cation. So it is not dependent upon the pH only, it is also dependent upon the the structure of the compound and the pH at which the Zwitter ion is present. You can say the Zwitter ion told earlier, the point where the net charge on the amino acid is 0 is called as the isoelectric point. So the point where the pH of the solution is such that the overall molecule is neutral, is called as isoelectric point. Now, isoelectric point depends upon this functional group present in the amino acid. So, as in an amino acid, it is not only the carboxylic acid and amine present. There can be also sulfur and other groups also. There can be two carboxylic group also. So, depending upon the structure, it will have different criteria for converting the carboxylic acid to the carboxylate ion, or you can say different base will be required, different strength of base will be required to convert the carboxylic acid into carboxylate ion, or different acid will be required to convert the amine group into ammonium ion. And depending upon that, we get an isoelectric point at which the overall charge on the molecule is 0. Next, it typically emerges between 5.5 and 6.3 for neutral amino acid. So we will see it later what is neutral amino acid and acidic and basic amino acid. For now, keep it in your mind that okay, the neutral amino acid have a pH of 5 to 5.5 to 6.3 for isoelectric point to take isoelectric point. Now, amino acid are least soluble in water at their isoelectric point. So this is an important point. You should be aware about it, that at isoelectric point it is the least soluble. Next, what is classification of amino acid? The first is the neutral amino acid, which I have told you earlier. So the neutral amino acid is that which contain only one NH2 group and one COOH group, like the glycine we have. So if you look at the structure of glycine, it looks like this. So it has one carboxylic acid and one amine. Similarly, we have valine, alanine, etc. Then we have the basic amino acid that contain one CHO group, okay, and more than two NH2 group, two or more than two NH2 group. So we have the example of lysine and arginine. So we will see the structure of this amino acid in the later on slide. I put up a table here so that you can get an idea of each and every structure. Last is the acidic amino acid, which has more number of COOH group than the NH2 group. So the common example is aspartic acid, glutamic acid. Now this was all about the classification of this amino acid. So this amino acid only has the isoelectronic point. That means at this pH, the neutral amino acids are present in Zwitterian form. That is, net charge on the amino acid is 0, and it will neither move towards the cathode nor move towards the anode. Now this is the structure of amino acid. So I have told you earlier that arginine is a basic. So you can basic amino acid. So why is it so? You can see here very clearly. It has 1, 2, 3 amine group other than the one, and also it is very much basic than the normal amine group. Why? Because the structure looks like this. Okay, the structure looks like this. Now both of this lone pair are donating electron on this nitrogen, and it is having a higher basicity, this arginine. Then we have the histidine, in which this nitrogen is the basic one. Then we have the lysine. Okay, so it has also one NH2 group extra. Now coming to this COOH group extra, this is the thing, that is aspartic and glutamic acid. So they are acidic in nature because they have two COOH group. Here also the glutamic acid has two COOH group. Now polar and uncharged means why it is written charged, positively charged and negatively charged? Because if we increase the pH, in this case, if we decrease the pH, then if all of these are protonated, then this COOH and NH2 of course will be neutralized, but the extra amount of H plus will be taken by this NH and it will be positively charged. Similarly, as at isoelectric point, this will have this O minus, this will have this plus, but this group will have a extra O minus, so it will be negatively charged. Now polar but uncharged, meaning that they are polar because of the presence of an extra functional group, that is OH, but it is uncharged. Why? Because this proton will not be abstracted at this pH of isoelectronic point. Then we have special cases which have this glycine, proline, okay, cysteine and selenocysteine. Some of are hydrophobic, okay, and they also contain a benzene ring. So all benzene ring containing group are hydrophobic in nature. So it is phenylalanine, alanine, triosine, and tryptophan. At last we have the hydrophobic part. So it is neither polar, not a special case, not positively charged, not negatively charged, and not hydrophobic. So so not hydrophobic. So the remaining one is called hydrophobic amino acid, which includes simple amino acid like alanine, valine, isoleucine, leucine, methionine. So this was all about this amino acid table. Now if you look at some points, so all of the amino acids are optically active because they have a chiral center. Sorry, or you can say asymmetric center. Asymmetric center means that devoid of all elements of symmetry. Whether it is C plane, whether it is plane of symmetry, whether it is say whether it is point of inversion or it is alternating axis of symmetry. None of these are present at this carbon, which is then it is called as asymmetric carbon. And asymmetric carbon will be considered as a chiral point, or you can say will create chirality if there is no plane of symmetry in the overall molecule. So I'm just giving you a backflash of this, say, stereochemistry. So in that case, if it is creating chirality, it is called as disymmetric. Or you can say that it lacks plane of symmetry sigma and I and Sn. Then it is called as disymmetric. And asymmetric means all four are now present. In disymmetric, C can be present. So all amino acids are, you can say, optically active except this glycine, which is having two see, it is look like this, CH, COOH, NH2. So this carbon, which carries the potential of becoming a chiral center, has two hydrogen. Means there are not four different groups. Next, most natural amino acid have L configuration. So what do you mean by this is that NH2 is on the left side. So if you draw the Fischer projection of any of these, then NH2 will be present on this side, like this. So it will look like this in the R group. That means all the naturally, or you can say mostly, amino acid group are have L configuration. Next, we will see what is amino acid. This is what is protein. So protein is nothing but a polymer of amino acid, and it is formed by the glycosidic bond linkage of these two amino groups. Suppose we have two amino group like glycine and alanine. Now this NH2 will attack on this COOH and form a amide bond here, which is called the peptide linkage between two amino acids. And in this fashion, if the polymerization goes on, then we get a structure of protein. So how do we say it? So polymer of amino acid are connected by peptide bond or peptide linkage. So it is mentioned here also. Next, if two amino acids are present, it is called as dipeptide. If three amino acids are present, it is called as tripeptide. Less than 10 amino acid means it is called polypeptide. At last, if it is having a higher molecular mass greater than 10,000 AMU or U, then it is called a protein. So this is an important definition of this protein. So it is a polymer of amino acid having a molecular mass higher than 10,000 atomic mass units or units. So this is about the structure of protein. Now we will see how this peptide linkage helps in the formation of protein. So before that, we have the classification of protein as S2, fibrous and globular. So what is fibrous? So fibrous are thread-like molecules that are side by side to form fibers. Now it is water insoluble. First of all, this is an important point. And the example of it is keratin that is present in hair, nail, woods, feathers and horns. Muscles have myosin, skin is composed of fibrion, and bones and cartilage have collagen. Now the fibrous proteins are held together by hydrogen bonds. So these are some important points of the fibrous protein. Now if we come to the globular protein, they are soluble in water, diluted acids and alkalis, such as insulin, hemoglobin and albumin. Now they have folded molecule into compact unit that are acquired spheroidal shape. Spheroidal shape means spherical in nature. So this is all about the fibrous and globular acid, global protein, fibrous and globular acid. Now we will see the structure of this protein from the basic to the complex one. So first is the primary structure. So it basically involves the linkage between CO, OH and NH2 forming the NH bond, that is amide bond. Protein structure, primary structure, linear sequence of amino acids. So you can see here, this is the primary structure which is a linear structure. It is linear and it is a sequence of amino acids. So there are many amino acids like this, again like this. So there are many units of amino acid and it is a straight linear chain. Now dipeptide, two amino acids are joined by a peptide bond. Polypeptide, multiple amino acids are linked by peptide bond. Now if we consider terminal here, so this is a C terminal that we are having. Now if we terminate it here, then it will be C terminal, and if we terminate it here, it will be N terminal. So this is the primary structure. Now if you look at the secondary structure, it is a 3D arrangement of polypeptide. So we have this kind of linear structure. Now that is arranged in some fashion. So in this case, we can have two fashions. First is the alpha helix and second is the beta sheeted. Now both of them are means held together by the hydrogen bonding. Now it is coiled. You can see a coiling is formed here. So a kind of coiling is formed here. Okay. So we see a coiling here. Okay, and the CO to the fourth residue NO group. So how it is formed? The hydrogen bond. So if it is the first nitrogen, okay, then it will just connect to the fourth one. So fourth fourth NH residue. So this is 1, this is 2, this is 3 and this is 4. So in this way they both are connected. Again we have here one more connection between NH and C double bond O. Okay, so this is the alpha helix. Now it is right-handed form, means if you grab your right hand like this on a rod, then in the fashion in which your finger goes is the same fashion in which the alpha helix will have the structure. Now next we have the beta plated sheet. So it looks like this. Okay, and occur with small R group in amino acid side by side chain arrangement by polypeptide chain. So this is the side by side chain arrangement in which hydrogen bonds are formed between two sides, between two groups of the same functional group. Only the bent part is allowing this thing here, beta plated sheet. Now intermolecular hydrogen bond between backbone Cu and NH. So you can see here there is a intermolecular hydrogen bond between Cu and NH. Similarly here also. Next we have the tertiary and the quaternary structure. So what is tertiary structure and what are the forces that are present in tertiary structure? We have the hydrogen bond, of course, then the disulfide bond which is SS, ionic bond, chemical bonds and hydrophobic bonds. The result, the compact and complex structure formed for the protein. Now tertiary structure only results in two kinds of this structure, which is fibrous and globular. Same thing written here. Largely helical structure, rigid rod shape, globular made of helical and beta sheeted sections. So globular is containing beta and this fibrous is containing alpha helical structure. Now talking about the quaternary structure, it is just means combination of tertiary structure. So we will look at a diagram so to get your concept more clear. Now it is the assembly of multiple polypeptide chain which is formed due to the interaction that is found in tertiary structure. Now held together by hydrogen bonds again, increases molecular mass. Examples are hemoglobin, which is having 4 subunits of 2 alpha chains and 2 beta chains. Again we have alpha chain of 141 amino acid and beta chain which of 1:1 amino acid. Now next, I have put up an example here of a protein which is called as hemoglobin. So here is the hemoglobin that we have. Then is the linear structure which is called the primary structure. Then the secondary structure, that is this helix that is formed. So this is a helix that is forming. Okay. Now next, this is just twisting and forming this kind of structure. So we can see here that upon twisting, we found this kind of structure which is called a unit. Now this one unit, likewise this one unit, we have four units, and they four of this combine to form the quaternary structure. So initially we have a primary structure. This primary structure folds to get your secondary structure. Now this again folds to get to tertiary structure. Now a unit of tertiary structure or more, one or more units of tertiary structure, come together to form a quaternary structure. Now okay, the protein is formed. Now this protein can be broken back, you can say, by denaturation. So it is generally done by heating, and it is changing the globular protein to the fibrous protein, resulting in precipitation or coagulation of the protein. And how does it happen? It happens in the action of heat, mineral acid, or alkali. So what is destroyed is the secondary and tertiary structure of the protein. So whichever protein you get, do not heat it or just expose it to an alkaline or a acidic condition. Otherwise, it will break down to give you a secondary primary structure. Now primary structure are not broken further. Only the secondary and tertiary structure are broken. So this was all about the example of hemoglobin. Now we will see what are enzymes. So enzymes are basically that compound that catalyzes a reaction, generally named after the substrate upon which it operates. So if it is operating upon lactose, it will named as lactase, and like this. For example, the enzyme that catalyzes hydrolysis, which is maltose hydrolysis, is called as maltase. Next, sometimes it is named according to the functionality, like it is oxidizing and reducing at the same time, then it is called as oxidoreductase enzyme. So if I see example, here's an example. So we have maltose. We'll take the maltase at the enzyme, and it will hydrolyze to give 2 moles of this glucose. Next, we have the vitamins. So vitamins were earlier considered to be the amines only, which are vital for our survival. But later on, the definition was changed and was removed with a different one. Now, what are this vitamin? They are taking the small amount in our diet to perform specific biological function. Now, they can be of two types: functional soluble vitamins and fat soluble vitamin and water soluble vitamin. So, fat soluble vitamin are A, D, E, and K. Water soluble is only B and C. So B group like B2, B6, B12. Okay. This is about the vitamin. Now we'll see the formation of DNA. So what is DNA and RNA? So here I have given a D. This is a deoxyriboglucose. Oxyriboglucose and deoxyriboglucose. So you see this oxyribo and deoxyribo in the next slide. So this is the deoxyribo for the case. Deoxyriboglucose. And this structure is called as nucleoside. Now, if this nucleoside is attached to a phosphate kind of group, then it is called as nucleotide. So this is the first important point, that if it is not attached, the DNA base is not attached. Sorry, the DNA glucose is not attached to any of the phosphate, then it is called as nucleoside. And if it is attached, it is called as nucleotides. Now we have two units of this, say the 2 units of this glucose having a phosphate, and a base, or you can say two units of a nucleotide. Now, two nucleotides will link through this 1-3-5 linkage, 3-5 glycosidic linkage or phosphodiester linkage. Okay, it will kind of it will form a phosphodiester bond here, and again this linear chain will go on and go on to give our double helical structure. And this both strands here are held together by hydrogen bonds. So some of the important points are here is that the two strands are held together by hydrogen bond. Which kind of hydrogen bond? So G and C have three hydrogen bonds bonding. A and T are having two hydrogen bonding. So this is about the DNA structure, which is having a two double helical like structure, and there is a G and C. So I will tell you what is G. They are bases. So G and C are having three hydrogen bonding, and A and T are having two hydrogen bonding. And this both these strands are complement to each other. How? So suppose we have a strand like this, which is formed from the base sequence GATACG and 3 dash. Then if you want the complementary one, suppose this is for this one. If you want this one, the complementary one, you will simply take the opposite 3 dash. G will be replaced by C and A will be replaced by T. A, T, C, G and 5 dash. So this is the complementary strand of this one. Okay. In this way you can light the complementary strand. So now we will see what is this base that we are having and what is the glucose group that we are having. Before that, let us look it by looking at the structural aspect of DNA and RNA. Suppose this is the DNA, that is the RNA. So the main difference between DNA and RNA is that there is no hydrogen bonding in RNA, means there is no double strand in RNA, only single strand is there. In DNA, we have a double strand which is connected together by hydrogen bonding. Next, for this DNA, we have this deoxyribose structure, and for the this RNA, we have the ribonucleic acid structure. Okay. Now, if we talk about the bases, so this DNA have four bases, which is thiamine, which is having a symbol of T, then cytosine, guanine, and adenine. These four bases are present in DNA, whereas the RNA has also C, G, A, but U at the last. Okay. So this is the difference between the number of the type of bases that is present in DNA and RNA. Now, this one is called purine bases. So three pyrimidine bases are present. So this one is pyrimidine. So pyrimidine bases are three. This one, and this one. And purine bases are two. Okay, so this is the structure of the DNA and RNA in a more simplified manner. Next, what is the difference between RNA and DNA? So here I put up a table here. So sugar backbone. So if you look at the sugar backbone of this RNA, it is mainly consists of hydroxyl group at two position, that is ribose. So ribose is the forming the frame structure. When in case in DNA we have the deoxyribose. So you have seen earlier. So if you want to look more clearly, you can see here, okay, that there is an H group that is present in this position, that is 2 position for the DNA, but for the RNA there is no such there is no H, but there is OH. This is 2 for RNA. So this is the difference of the group that we have between RNA and DNA first of all. So single stranded can fall into complex shapes. So you know it very well that single stranded can form it a complex structure. Next we have the bases. So you should remember these names: adenine, guanine, cytosine, and uracil. And for DNA, we have the adenine, guanine, cytosine, and thymine. So the difference is uracil and thymine. RNA is single strand, DNA is double strand. Function: it carries genetic information and participate in protein synthesis, form regulatory test. DNA stored genetic information serves as the blueprint for the life. Stability: it is less stable because DNA is having a hydrogen bonding which is stabilizing it once again. This DNA is more stable, passes genetic information from generation to generation. What is the location? It is found in cytoplasm, nucleus, and ribosome, where the DNA is found in nucleus and chromosome. So it is mostly found in the nucleic part of the cell. Now, types of RNA: we have messenger RNA, ribosomal RNA, transfer RNA, and the microRNA. Whereas the DNA have the genomic RNA, mitochondrial RNA, and the plasmid RNA, DNA. Now we look upon some questions here. So I have put upon some questions to get a more clear picture of the concepts. So here is the thing. So what is invertage? What which one is doing the maltase and which one is for pepsine and all? So we know that maltose stand for maltase. First of all, B. Then we have the gymase. So what does gymase does? So it is for ethanol. Hydrolysis. Okay, hydrolysis for what? This is hydrolysis of protein into amino acid. It is done by pepsine and it is done by cane sugar. So it is a kind of learning thing. So you should remember it. So A goes with three. A goes with three. Okay, A goes with three, B goes with two, and C with four, and D with one. So this is about the first question. Next, the second question: the secondary structure of protein refers to. So the second structure can be alpha helix and beta sheeted. Okay, so it refers to alpha helical. Okay, it is true. It is hydrophobic. No, it is hydrophilic. Sequence of amino acid. No, it is not about a sequence of amino acid. Sequence of amino acid is in the primary one. Now, fixed configuration of this polypeptide backbone. Okay, so this is the last point. So this one is correct here. Alpha helical bone. The same thing is written that secondary structure form two types of structure. The first one is alpha helical and the second one is beta sheeted. So alpha helical can be formed and it is held together by hydrogen bonding. So it should be also remembered in mind that it is held together by hydrogen bonding. Next, which one of the following statement is true? The first one is that all amino acid except lysine and are optically active. So this is false because glycine is optically active. All amino acids are optically active, so it is also false. All amino acids except glycine are optically active. So this one is true. Next, all amino acid except glutamic acid are optically active. So it is also not true. So this is right. Which if the following vitamins are water soluble? So A, D, E, K are water soluble and C is not water soluble. So this is the correct option. That is a kind of memory based question. Next, adenosine is an example of what? So adenosine is an example of what? Nucleoside, nucleotide, purine or pyrimidine. So adenosine is a base and it is a purine base. Sorry, nucleoside, it is a nucleoside while adenosine triphosphate is a nucleotide. Sorry for the confusion. Okay, so adenosine is a kind of nucleoside. Adenine is a base. Now I will show you some questions and give you a hint. You should solve it by yourself. The presence or absence of hydroxyl group on which carbon of sugar differentiates RNA and DNA. So if you look at the RNA structure, it is kind of furanose one. And at this place, we have the chain. That is first, this is second. So you should remember the structure in a minute fashion. Okay, so structure are important for this chapter. Next, which one of the following bases is not present in this DNA? So this is a straightforward question. You can do it by yourself. This, of course, quinoline. No such base is existing in this RNA or DNA either. Next, which is water soluble and antioxidant. So this is a kind of means memory based question here also. The base adenine occurs in. So all of this question are memory based. At last, the type of bond that is most important in maintaining secondary structure. So it is, of course, is hydrogen bonding within the backbone. So this was all for today. If you want, you can ask some questions.